Okay, great. Ladies and gentlemen, this is Labs Mining, and today in engineering mathematics, we are going to continue with limits. And the question under discussion leads solve ln x less the power 3 over the square root, or let me say the cube root of x, limit as x approaches positive infinity. Okay, so before we even go to our solutions, ladies and gentlemen, what we can do is we can just kindly share as well as liking, and if possible, also subscribing to this channel so that you keep being updated with the videos that we keep uploading. Okay, so in this case, what we're going to do is we're going to analyze the expression that we've been given. Okay, so the expression leads limit as x approaches what? Positive infinity. You also have ln x 3 over the cube root of x over 3, pardon my x. Okay, so we have that. Okay, so in this case, what you have to do is just understand that this positive infinity simply shows the direction. Okay, it's just showing the side of the number line that we're dealing with, and that means the positive side of the number line where the numbers are infinity or the limits are infinity. Okay, so that is as better as sometimes lighting this positive infinity as just positive zero. It is also something that means math error. Okay, so once you do that, the next thing that you have to do is make sure that you interpret the denominator part, you remove it outside or remove it away from the square root so that you can have something that will look like this. Okay, you maintain the upper part. Okay, so down, what I'm trying to say is according to the laws of indices, we are going to have x raised to the power 1/3, which is 1 over 3. By so doing, then the next move that we're going to do is we are going to differentiate, okay, the numerator independently as well as the denominator independently, because if we can replace zero direct, then we might get an infinite, or let me say we might get an undefined expression. It is for that reason we are going to differentiate the numerator by using chain rule, and this chain rule says if you have got a power such as 3, you are going to bring it in front, okay, of everything I mean ln x, like that. Okay, and then immediately it comes in front, you are going to disturb it by subtracting by 1, so then you are going to maintain 2, like that. Last 3, what you have to do is go back to what is there or what is there. Okay, differentiate this part as well. So this is a natural log ln x. So the dy over dx of ln x simply means 1 over x. Okay, so you have that, then you are done with the numerator part. You come to the denominator part where I've got x raised to the power or the exponent of 1 over 3. So in this case, you can just apply power rule, where you can say I'll allow this 1/3, which is 1 over 3, to just come in front. So if this 1/3 comes in front of x, then you can suggest to do what? To reduce it also by 1. So you can say this is 1/3 minus 1, and then say over 1, 3 down there. Then the next move is you just do some simple mathematics where you can say 3 into 3, 1 times 1, 1, and then say 1 into 3, 3 times what is 3, and then that is a negative 2 over 3. You can bring it there. It means you have reduced that 1/3 to negative 2 over 3. Okay, so you have that expression. So as you do that, remember that you are dealing with a negative power down. So it's very advisable to take this negative power on top so that it becomes what? A positive power. So we are going to say we are having something that will look like this, something that will look like that. Okay, we have got this expression, and then remember to take, by the way, you are not taking 1 over 3, you are just taking this part which is having a power. So you are going to take x, okay, and then a 2 over 3 as a positive, like that. And in this case, you are going to say, I'm having 1 over 3 down there. A reciprocal will take place. To my side, what I do is, I just count the stages. Okay, 1, 2, and 3. It means this final stage will multiply the upper stage. So, which means you are going to have a 3, which will multiply a 3, and then you have a 6, a 9. Okay, so you are going to have a 9 like that, and then you are going to have erin x, and then you're going to have a 2. You are going also to maintain your 1 over x as well as x 2 over 3, and then there'll be 1 down, which is same as the same expression. So at this juncture, colleagues, what we have to do is just write again limit, okay, as x approaches positive 0, which was formerly a positive infinite, and then you start now replacing wherever there is x with wherever there's x with 0. So in this case, we're going to have 9 in 0 squared 1 over 0 x, okay, 0 is the power that we have replaced because we have done our best. We have already differentiated. So in this case, you are going to have a 9, and then in 0, as we know using the calculator, in of 0, as usual, it is a math error, which is same as just 0. So this is a 0, and then all of them there, they will continue being what? Zeros. So in short, 9 times 0, like that, it simply means we're going to have what? A 0. So in short, if you have got a 0, or if your final answer ends with a 0, it means such type of limits does not exist. Thank you for your attention, and see you in the next video.